All right, so here we go with your quiz 14 study guide. All right, problem number 1. We've got circle O here. And tangent AB. And then B connects to O, hits the circle at C. And we're told that if A to O is 36, BC is 75, find AB. All right, so if A to O is 36, then O to C is also 36. If BA is the tangent, then this is our 90-degree angle. And this entire hypotenuse right here is the sum of 75 and 36, which is 111. So if we need the length of AB, AB squared plus 36 squared is equal to 111 squared. So you can subtract 36 squared from each side. AB squared is going to be equal to 11,025. And then we're going to find the square root of each side. So AB will be equal to 105. Try to remember to add these two together, the 75 and the 36, or whatever the numbers they are. And again, where the tangent intersects the radius forms the 90-degree angle. And the two segments that form the 90-degree angle are the legs. Number 2, we've got another circle O. And a diameter running through. That is AC. We've got a radius from O to B that forms a 75-degree angle. And then we need another segment that connects A to B. And we need the measure of angle BAC. So the measure of angle BAC, here it is. The measure of angle BAC is this inscribed angle. And an inscribed angle is equal to half the measure of its intercepted arc. So half of arc BC is equal to the measure of angle BAC. So look, if AOB is 75 degrees, then the angle on the other side here, BOC, angle BOC is equal to 180 minus 75, because those two are a linear pair. So that's 105. So if this angle here is 105, what that tells us is that arc BC is also 105. So the measure of angle BAC is going to be equal to 1/2 of 105. $52.5. Problem number 3. We've got a circle with a chord, and a segment from the chord to the center is 8 units long. From the center to the edge of the circle, we've got a radius that's x units long. We're told this chord is 15 and it intersects with this piece of the radius at 90 degrees. So what we talked about last week was that when a radius intersects a chord, it forms a 90-degree angle. So what they're saying is that this 8 is just a section of a radius. That it intersects at 90 and it bisects this chord. So now if we need x, since x goes from the center of the circle to the edge of the circle, we can redraw it over here and make it the hypotenuse of this right triangle. And it's going to be the same length. And if we take the 15 and we divide it by 2, it gives us this blue portion of this right triangle. So that's going to be 7.5. So now Pythagorean theorem again. 8 squared plus 7.5 squared equals x squared. So 120.25 equals x squared, and then we're going to find the square root of both sides. So 10.97. We're rounding our answer to the nearest tenth. So this is going to round to 10.97 equals x. Rounded to the nearest tenth would give us 11. Problem number 4, we've got circle O again. And we've got segment AB, which is a tangent at B. And then B connects to O, and that segment's labeled lowercase r. If we connect AB, then we've got a tangent and a radius intersecting, and they form a 90-degree angle. Find the length of the radius for AB equals 8, AO equals 9.9. So A all the way to O is 9.9. And you're finding R. So 8 squared plus R squared equals 9.9 squared. I'm going to subtract 8 squared from each side. And R squared equals 34.01. And we're going to find the square root of both sides. So our radius is equal to 5.8. Number 5. We've got a circle with a triangle around the outside of it. So kind of like this. And your triangle is labeled JLK. And your tangents are labeled ABC. What you're told is JA is 14. AL is 14. And CK is 15. And you need to find the perimeter. Of triangle JLK. All right, so what we've got here are tangents coming from the same exterior point. So tangents to a circle that come from the same exterior point are congruent. So if J to A is 14, J to B is also 14. If L to A is 14, then L to C is 14. If K to C is 15, then K to B is also 15. So we need the perimeter of this triangle. So this side that goes from J to K is equal to 14 plus 14, which is 28. The side that goes from L to K is 14 plus 15, which is 29. And the side that goes from J down to K is another 14 plus 15, which is 29. So this perimeter is equal to 28 plus 29 plus 29. $86. All right, number 6. We've got a circle with a chord. The chord is CD. Got a segment going from left to right labeled AB. We're going to connect C and A. And then we're going to connect A and D. And this point of intersection in the middle is P. All right, here's what you're told, that the measure of angle BAD equals 46. Find the measure of angle BCD. All right, so BAD, we're going to start at B. We're going down to A and then to D. So here's the end of the angle right here, BAD. It's 46 degrees. Why that's important is because it means that the arc BD, this intercepted arc out here, is 2 times 46, which is 92. So here's this arc. It's 92. You need to measure a BCD. And I'm sorry, there's actually a line that connects D and B and another line that connects C and B. So here's the angle that they're asking you for, BCD. We'll look at angle BCD. Doesn't it intercept this same arc right here? So that makes its measure half of the 92, doesn't it? So the measure of arc BCD is congruent to 46, which is 46. Two angles, two inscribed angles that intercept the same arc have the same measure. Number 7. Big circle on the left, little smaller circle on the right. The big circle is circle A, and the smaller circle is circle D. We've got a dashed radius from circle A to point B, and a dashed radius from circle D to point C. B and C are connected. And here's what you're told. BC is tangent to circle A at B and circle D at C. So BC is tangent to both circles. AB is 12. B to C is 23. And D to C is 5. DC is 5. Find AD. Well, we're going to build AD. All right. And we're going to build AD like this. We're going to connect A and D. And then since A to B is 12, we can draw this radius in right here. And it would be 12 as well. And then we can take a point from the end of that radius that we just drew, and we can connect it to the middle of circle D. So what we're doing is we're using a radius and a tangent to form a right triangle so that we can find the distance from A to D. All right. So since the distance from B to C is 23, the distance on this new triangle we formed would be 23. So what we get here is a right triangle. And we can say that 12 squared plus 23 squared equals AD squared. So our 12 squared plus 23 squared is 673 is equal to AD squared. And then we can find the square root of both sides. So 25.94 is equal to AD. And in this case, we're rounding to the nearest tenth, so that's going to be 25.9 equals AD. Yeah. Because all we're really doing is we're sliding it from one position to another. We're kind of rotating this down to D, and then we're rotating B down to, oh, I can call this probably E. So since they're both getting rotated along a radius, then that distance is going to stay the same. All right, number 8. we've got circle O again. And we've got point N connected to O, and O goes to Q, which is on the circle. Then from N, we're going down here to R. And from R, we're connecting to Q. Measure of R is 39. Find the measure of angle O. All right, so what we've got here is this angle R that intercepts arc NQ, and angle O that intercepts the same arc. So if R is 39, then NQ is twice as big as 39. So 39 times 2 is 78. So if arc NQ equals 78, and angle O here is a central angle, then those two angles have the same measure, don't they? So angle 8 is 78 degrees as well. Angle R is an inscribed angle, which is half the measure of its arc. Angle O is a central angle, which is the same measure as its arc. And number 9, another circle O. Circle O has a diameter that runs through it from A to C. And then we're going from O to B, which is on the circle. And then we're going to connect A and B. We are told that BOC is 51 degrees. And we need the measure, find the measure of angle BAC. All right, so angle BAC starts at B. We're going down here to A and then back up to C. All right, so angle BAC and angle BOC, they both intercept this same arc. So if this central angle is 51, then arc BC is also 51. Which means the measure of the inscribed angle is equal to 1/2 of 51. So the measure of BAC is equal to 25.5. Yeah. Central angle has its vertex on the center of the circle. Inscribed angle has its vertex on the circle. That's the difference between a central angle and an inscribed angle. Central angle has a vertex on the center. Inscribed angle has a vertex on the circle. All right, number 10. In number 10 here, we got point D on the left of the circle and point B on the right of the circle, and we're going to connect them. We've got A in the upper left of the circle, and we got C in the lower left of the circle. And we're going to connect A to D, D to C, C to B, and A to B. given that DAB and DCB are right angles. DAB is a right angle, and DCB is a right angle. Now, if you're told that those two are right angles, that means that DB is the diameter of the circle. The measure of BDC, BDC is 49 degrees, right here. What is the measure of arc CAD? You need the measure of arc CAD. All right, so let's identify the arc that you need first. You need, starting at C, all the way around this circle, through B, through A, and ending at D. So you need all of the circle, don't you? Except for this purple part. So 360 minus purple would give you blue, wouldn't it? All right, so look, here's what you got. If you know that this angle is 49, then this portion of the arc is twice as big as 49, isn't it? So the green portion of the arc would be 49 times 2. Hmm. 49 times 98. So the green portion of the arc is 98. Now, since these were both right angles, that told us that DB was a diameter. And if DB is a diameter, then isn't this dimension or this measure right here 180 degrees? So if we take 180 and we subtract 98, it gives us the purple arc, which is 82 degrees. So we said early on that blue, or I'm sorry, that 360 minus purple would give us the blue, wouldn't it? So the measure of this arc, CAD, is going to be 360 minus the purple piece, which is 82. Which is 278 degrees. All right, we got 2 problems left. Problem number 11. Circle O. We've got a chord across the top of this circle, AB. We got a segment from O that intersects AB at 90 degrees. And they intersect at point C. And then we got a radius that connects O to B. The radius of circle O is 28. The radius of circle O is 28. So that means that from O to B is 28. O to C is 13. Find AB. All right, we're looking for A to B. Well, C to B is going to be 1/2 of A to B. Because when a radius intersects a chord at 90 degrees, it bisects the chord and the intercepted arc. So CB plus CB squared plus 13 squared equals 28 squared. So we can subtract 13 squared from each side. And CB squared equals 28 squared minus 13 squared is 615. We're going to find the square root of each side. So CB equals 24.8. Now that's just this portion, 24.8. But you need AB. So A to B is going to be equal to 2 times 24.8. Which is 49.6. All right, and last but not least, number 12. And one more circle O. And we've got point Q on top of this circle, and it connects to O, forming a radius. And then we've got point P out here, and P connects to Q. It forms a tangent. And then P connects to O. So you're told that assume that lines that appear to be a tangent are a tangent. So if PQ is a tangent, then it forms a 90-degree angle. You're told that the measure of angle P is 28 degrees. And you need to find X. All right, so we know that the two acute angles in a right triangle sum 90. So we take X plus 28, make it equal to 90, and subtract 28 from each side. So our X in this case is equal to 90 minus 28, which is 62 degrees. All right, and that concludes your study guide for quiz 14.